Oh, I got one more thing. I want to go ahead and give you our chapter 9 stuff. I don't know if he's going on retreat. So, Grace, did you want to give that to everyone? Ellie,
Side effect.
and I want him to
Out of this class, I can care less about
Your
any
chapter
other.
9.
I'm done with all.
This area.
We wouldn't be talking about what to do that chapter.
You're in everyone. So, you should have, what's this? 3 different packets. By the time we're all done.
George. You have this site test where you can't use your iPad. Dude.
So is everybody gonna have 3?
That's the least.
Everybody have 3? Alright, good to go. Alright, thank you girls for your help. Now I am ready, finally. Who has something we need to talk about? Jacob.
Allowed to go over questions.
Yeah, we go over anything we need to do to review. I'm not sure, I got different quizzes. What quiz are you looking at? How many hearts does it have?
One.
One, alright, I don't seem to have that one, so who's got a 1 heart quiz? Which one am I doing, number 7?
Yeah.
Alright, so let's take a look at problem number 7 on the 1 heart quiz, but the 2 heart quiz had one just like it. So 3x minus y squared equals 5, and x plus 2y equals 4. Okay. So, this is a system of equations, and we're going to solve it, but, well, I guess we could eliminate the x's, right? That's always my favorite thing to do is to eliminate, and since these are both plain x's, we can do that. You could also get this x by itself and substitute it in here. I wouldn't recommend getting this y by itself because you're going to end up with fractions and then you're going to have to square it. So I think that would not be a good idea, but certainly you could get x by itself and substitute. I'm going to go ahead and multiply this bottom row by -3 because I remember this is where some of you made mistakes. -3x minus 6y and -12. Does that look okay to everybody? Now, when I add those together, I multiplied that bottom row, hopefully correctly, by -3. When I add these together, those are gone. These do not add together, so they stay separate. -y squared minus 6y equals -7. Everybody still with me? Now, that's a quadratic equation. So when I have a quadratic equation, I get it set equal to 0, and then I can solve it however I want, but I want to get it set equal to 0, so I'm going to shift everything over here. So I'll have y squared plus 6y minus 7. Now, again, you can solve that however you want. The quadratic formula is always available to you. This one I think does factor though, so it might be easier just to factor it. But again, you don't have to factor it. So that means I'm going to have 2 answers. And the y's are going to be 1 and -7. So then I'm going to plug back in probably this equation right here, x plus 2y equals 4. If y is 1, then it looks like x is 2. And if y is -7, then it looks like x is 18. Did I do that right? And there it is. Okay? All right, who else has something? Read.
So on this packet,
The review packet?
just the front page,
Okay.
number, question 5.
Question 5 says find C times A. Well, before I take the time to write all that out, let's figure out if that's even possible. So what are the dimensions of C? 2 by 2. What are the dimensions of A? Okay, so it's possible, because if I have a 2 by 2 and a 2 by 3, those are going to multiply. So I guess I'm going to have to write it all out now. All right, so C is this, and A is this. And since those match, I'm going to multiply, and my answer is going to be another 2 by 3. So my answer is going to be the same size as that one. So I have 6 numbers that I have to find. Right? And when I multiply, first of all, I figure out what spot I want to fill. Okay, I'll start right here. I'll fill this spot. That is first row, first column. So I'm going to multiply the numbers in the first row times the numbers in the first column. And if you at all struggle with this, I would 100% recommend you write it down. So there are the numbers in the first row. Here are the numbers in the first column. Multiply each pair and add them, so it looks like this is going to be a -2. And then I move on to the next spot, which is still in the first row, but now I'm in the second column. So it looks like that number will be -5. Okay, everybody remember this? And then so on. That's how you do it. You got that reading? So when I'm down here, I'll use my bottom row in the same columns. So to fill that spot, that's second row, so that's going to be 2, 7 times first column, which is 1, 3. So that's 21, 23. That number's 23. David?
Question 2 on that page.
C minus B, not possible. Because if you're going to add or subtract, they have to have the same dimensions. They can be any size, but they have to match. Oscar?
Can you number 2 on the 7-4 homework?
7-4 homework. Number 2. 7-4. Number 2. All right, so we're finding the partial fractions. The thing is, x plus 17 over, I'm going to go ahead and as I copy the problem down, I'm going to factor my denominator because that's the first step. That's what's going to tell me what is going to be in the bottom of my 2 fractions. So that's going to factor as 2x and x and plus 3 and minus 1. Let me double check that real quick. Yeah, I think that's right. Those are the factors. So one of my fractions, and the order that you do this is totally not important. So one of them goes here, and one of them goes here. If you have these turned around, then your A is going to match my B, because whatever you put over 2x minus 1 is going to be the same for you and me. So the order doesn't matter. All right, now I'm going to multiply everything by that denominator. So I'm going to multiply by 2x minus 1 and x plus 3. My goal here is to eliminate the denominators, get rid of the denominators. So this one's completely gone. So I have x plus 17. Now this is gone, so I have left ax plus 3a. And this one's gone, so I have 2bx minus b. Everybody keeping up with this? Is this okay with everybody? You need to stop me if it's not. Okay, all right. So now, keep in mind this is an equation. So the x's on the left, which is 1, have to equal the x's on the right, which are a plus 2b. The x's aren't part of that, it's the a's and the b's, it's the coefficients that need to match. And then the things that don't have x's, like 17 and 3a minus b, they have to match. So what have we got there? System of equations. You solve it any way you want. You know what I'm going to do, because I always do it. I'm going to eliminate, but you don't have to. You could certainly substitute if you wanted to. I'm multiplying the bottom one by 2. Remember, these have to be the same. If you're going to eliminate, these have to be the same, and one has to be positive and one has to be negative, or else they won't cancel. So they do. So I have 35 equals 7a, so it looks like a equals 5. And if a equals 5, it looks like b has to be negative 2. And this is the one time that we don't write our answer as an ordered pair. Our answer is, what was my a? 5. So our answer is 5 over 2x minus 1 plus negative 2 over x plus 3. That's your answer. Those are the partial fractions. Those are the small fractions that will add up to give you your big fraction. Okay? All right, Jacob?
Can we do
Number 1 where?
7.4.
Homework?
Yeah.
Okay, we just did a quiz over this.
Well, I didn't know if the particular thing is right or not.
What?
Well, when I was looking over the problem, I was looking over the steps from A to B. I didn't know if a particular step I should use correct. From 1 to negative 1. Would that be just 2 or negative 2?
Okay, I think I know what you're talking about. Okay, so as I move from A to B, I'm finding vector AB. As I go from A to B, from negative 2 to positive 2 is how many steps? 4, positive. And from 1 to negative 1 is negative 2. You're backing up. If you're going from positive 1 to negative 1, think of your number line. Here's 1, here's negative 1. Aren't you going this way? When you go that way, it's negative.
I had put positive 2 on there. So
Okay. That would make a difference then, because when you find the determinant, that would be a different number. All right, who else has a question about anything in any of this stuff? Homework, quiz, review.
For the 2x2 matrix, is it only the inverse method where the top left and bottom right flip, and then the bottom left and top right switch signs? Okay.
Only when you're finding the inverse. Only when you're finding the inverse. Okay, Declan?
Oh, so on the spring break, the problem that they want in the review packet?
What page is that?
5.
Page 5,
So, number 4, this is like evaluate. So what do we need to like do for that problem?
You recopy the first 2 columns.
Is it just the determinant we need to find?
That is the determinant, yes.
Okay.
Remember, those vertical bars mean determinant.
That's all. Okay, I just didn't know.
Yep, that's it. So you're just evaluating that determinant. Yep,
Cool.
yep. Jacob?
Can we go over number 8 on the review packet? It's like the page before 9.
What page? Their number, Jacob. What page number is it?
8.
Page 8? Okay, I don't have a page 8.
It looks like doesn't say.
Well, it doesn't say 8. It just
It's like the back of page.
So it's the back of page 7. Okay, so the back of page 7, and what number, which one am I doing?
8.
8, okay, that's exactly like the one I just did,
Okay.
okay? So I start by factoring the denominator, and I want to make sure that I factor correctly, so make sure you kind of foil that back, and make sure it gives you what you want. The order doesn't matter, so we're not going to worry about that. We're just going to put make one fraction have a denominator of x plus 3, and one fraction have a denominator of x minus 2. And then we're going to go through and multiply by that common denominator. So some of you can do this in your head, and I'm perfectly okay with that. I like to write it down so that I can see everything disappearing. So the x plus 3's are gone, so I'll be left with ax minus 2a. Remember, this is just a number, so you're going to distribute it. So that's bx plus 3b. All of this is an equation, so pretend I'm an equation, I'm in balance here. So all the x's in my left hand have to weigh the same as the x's in my right hand. So 9 has to be a plus b, I guess. And then 7 has to be negative 2a plus 3b. Jacob, you got it? So then I just do my substitution or elimination, whatever I want to do. So it looks like, ooh, b is going to be 5 again, it looks like. And if b is 5, then a has to be 4. So my answer is 4 over x plus 3 plus 5 over x minus 2. That's the way I write the answer to that question. Ellie?
Where did you get 7?
It's supposed to be 17.
Oh, is it supposed to be 17? I don't even know where I'm at. Oh, it is supposed to be 17. Just a miscopy, so that's a 17. So how is that going to change anything? It's not. So make this a 35, make this a 7, and then this is a 2. So that would be 2 and 7 would be your answer. Just a miscopy. Grace?
Can we do the number 10 on the same page?
Yep. So this one's all set up, it looks like. So we just need to start filling in the chart. So why don't you go ahead, read the problem, and start filling in the chart while I get everything drawn up here. Okay, so let's see. A, B, C, cost, yep, X, Y,
These ones.
okay. So it seems like you should have, no problem filling this one in. So let's see, he needs 4 milligrams of A, so his need is 4, he needs 11 of B, and he's 100 of C. Either 2 brands of pills can be used. Brand X is 6 cents a pill. Brand Y at 8 cents a pill. Now I'm putting that in as 6 and 8. If you prefer 0.06 and 0.08, that's fine. Whatever you want to do. Brand X supplies 2 A's, 3 B's, 25 C's. And Y supplies 1, 4, and 50. how many pills of each brand should you take each day to satisfy the minimum daily need most economically? So what's most economically mean? Cheapest. So we want to minimize the cost, and our cost is 6x plus 8y. Or if you're using decimals, 0.06 and 0.08. Okay? So what are my constraints going to be? Read them straight across. Here we go. 2x plus y is greater than or equal to. Kids, this is a minimum daily need. So if Ted wants to stay healthy, he has to have at least 4, which means 4 or more. 3x plus 4y is greater than or equal to 11. And 25x plus 50y is greater than or equal to 100. And then our gimmies, obviously, the number of pills I take are positive. I can't take negative pills. Okay, so here we go. I'll do my best. It's hard without graph paper. I think I can use a scale of 1 because these are still going to be small numbers here for the intercepts. So here we go. I'll do this one in purple. If I cover up x, y is 4. 1, 2, 3, 4. If I cover up y, x is 2. Connect them. And where do I shade? I shade above. So while we're kind of used to shading that little triangle, not this time, we're shading out. I'm not, because it makes a mess on the board, but this is where we're shaded out here. This is all purple. All right, so what's green? Well, 11 is kind of an unhandy number. I wish that were a 12, but it's not. So here we go. We're just going to have fractions, no big deal. So if we cover up y, x is 11 thirds, which is what? 11 thirds is 3 and 2 thirds. So that was y, so 1, 2, 3 and 2 thirds, so it's about right here. And if I cover up y, oh wait,
I think
that's what I just did. So this is 3 and 2 thirds. And then if I cover up x, y is 11 fourths, which is 2 and 3 fourths. All right, so I'm going to connect those now. And where's that one shaded? Out, yeah. So right now I've got this right here shaded. All this right here is shaded. Okay. Now I've got this one. This one's going to have nice round numbers again. So cover up y, x is 4. And cover up x, y is 2.
Oh, it was horrible.
That's supposed to be a straight line. And where is that shaded? Above. So everything is shaded above. So I think my corners of the shading are here, and here, and here, and here. Does that make sense to everybody? So my answer is either going to be 0, 4, or 4, 0, or one of these two. And these two are, well, this one is the intersection of purple and green. So this one is the intersection of these two lines, my purple line and my green line. That's this point right here. This one is the intersection of green red. By the way, that equation is divisible by 25. So if it's easier for you to work with it, divide by 25, it's the same equation. It's up to you. Okay, so far everybody's good? Everybody's with me? All right, so what do I need to do now to find these 2 points? What am I gonna have to do? I'm gonna have to substitute or eliminate or Cramer's rule or something, right? So this one, I can multiply the top row by -4. So -5x equals -5. Oh, that worked out nice. So for this point, x is 1. And if x is 1, y must be 2. Now here's what I mean about this equation, guys. I can divide everything by 25. And that looks like this. And then I can use that form of it with this one, if it's easier for you. If it's not, then do whatever you want to do. It doesn't matter. But it's a little easier to eliminate when we've got rid of that 25. So -2x, -4y, -8. So it looks like x equals 3. And if x equals 3, is y 1/2? So 3 1/2. And don't worry, 1/2 is okay. I don't know if you ever had to take medicine before, but sometimes you only take half a pill. It's okay, take only half a pill, if that's what the doctor told you to do. All right, so here we go. How do I get an answer now? How do I decide? One of those is my answer. How do I do it? Plug them into the cost equation, keeping in mind that these are the x's and these are the y's. So this, if I took 0 x's and 4 y's, that would cost me 32 cents. 4 and 0 would cost me 24 cents. 1 and 2 would cost me 22 cents. And 3 1/2. Is that also 22? 3 is 18 plus 4, yeah, 22 cents. So what are we gonna advise this patient to do? Either take 1x and 2 y's every day, or take 3 x's and half a y every day. If Ted doesn't want to mess around with half a pill, he'll probably choose this way, but it's going to cost him the same either way in terms of expense. So you would just write that. I'm going to tell Ted to either take 1 pill, 1x and 2 y's, or 3 x's and half a y every day, because both cost him 22 cents.
Can you say like X's and Y's on the test?
Yeah, because this is brand X pill and brand X pill, Y pill. In this case, that's how they're identified in the problem. Brand X and brand Y. Now, if it's corn and peas or something, we don't want to say X and Y, we want to say corn and peas. Even if we've let X stand for corn and peas. Okay? Read.
Can we do, notes, Cramer's rule?
I can just make up a Cramer's rule problem.
Okay.
All right, how does Cramer's rule work? Somebody help him out. I got a system of equations, and the directions say solve using Cramer's rule. What does that mean? What do I need to do? First of all, I find the determinant of the coefficients. So whatever the coefficients are in the equation, I build that determinant. So 2x minus 3y equals 7, and x plus 6y equals equals -1. So the first thing I do is build a determinant of the coefficients. And then I evaluate that determinant. So read how do you evaluate that determinant.
You go 2 times 6
2 times 6, so I have a 12.
minus -3.
Minus -3, so that's gonna be a 15. So the value of that determinant is 15. And what do I use that for? That's the denominator. Remember, we're solving a system of equations, so our answer is gonna be an x and a y, and in this case, they're going to be fractional answers, or at least they're gonna start out that way, and their denominator is 15. All right? Brenda, how do I start finding the numerators now? That's the denominator. How do I do the numerators?
You place one column with the 7 and the -1.
Exactly. So if I am doing x, I'm going to cut these out and paste them on top of the x numbers. So I'm going to have the 7 and the -1, and then the y's are just going to stay put. If I'm doing y, I do exactly the same thing, only the 7 and the -1 go in for y. That 7 and -1 replaces whatever variable it is you are solving for. And then you evaluate those. So this one's going to be 42 minus 3, which is 39. And this one's going to be -2 minus 7, which is -9. Now, if they reduce, please reduce them. So both of these reduce. So that would be 13 over 5 and -3 over 5 as my answers. All right, who else? Andrew?
Can you do like solve by like hand using like inverse?
Yep, we can do the same system, because now we know what the answer is, so let's do the same system with the inverse method. Well, I shouldn't have erased what I just did. Because the first step, well, first of all, remember that when you use the inverse method, your answers are simply going to be the inverse matrix times the constants. That's what you're gonna do every time. So I just need to find the inverse of that matrix I just erased. The coefficient matrix. That is not what goes here. What goes here is the inverse. This is gonna be the inverse here. So to find the inverse, what do I do? What are the steps to finding the inverse? Because that's what I need to do to figure out what goes here.
Can you switch the column?
Well, so one of the steps is I have to look at the adjoint matrix, I'll put it over here, which is, these two get switched, and those two their signs get changed. So that's called the adjoint. But that by itself is not the inverse, right? What do I have to do to that? Divide it by 15. They all get divided by the determinant. And I already did the determinant in the previous problem, so I know it's 15. 12 minus -3. Now, little trick, might save you time, might not. If the directions are find the inverse, if your job is to just say A inverse equals, you want to simplify all that. But if you're using that inverse to multiply, it might be easier to leave the denominators the same, because remember, part of the multiplication process is adding. Remember, you add the pairs. So it's easier sometimes to leave it with the common denominator if you're gonna have to deal with the fractions. So I'm gonna multiply these. They're always multipliable. It's a 2 by 2 and a 2 by 1. So I have two numbers to find. So I'm gonna multiply those times these. So 6/15 and 3/15 times 7 and -1. That's gonna give me 42 minus 3, so that's gonna give me 39/15. And then I'll take my, my bottom row. I'm finding this number now, so I'm gonna take the bottom row times my 7 and my -1. And that's gonna give me -7 and -2, so -9/15. And you see how I get exactly the same answer? I need to reduce that, like I did before, but that would be exactly the same. All right, what else? Anybody any of you people need anything? Salar, are you there? Caleb, where are you? All right, who else? Yeah, Grace?
On the spring break problem with the page 5, number 1 with the Gauss Jordan reduction.
That's the RREF.
Oh.
I did not use that vocabulary with you because I just didn't have time to go through all the vocabulary. But yeah, Gauss Jordan reduction. So you know that whole string of things, and I just picked RREF because I'm only going through that one method. So there's Gaussian elimination, that you use the REF button. Gauss Jordan, you use the RREF. So yeah, those directions won't be on the test, but that's all that means. Yep. So nothing, I noticed I thought on one of these sheets there was Gaussian elimination. Don't worry about that. We're gonna just do it the way we've been doing it. Yeah, and I don't know, I just had to skip some things, so. All right, what else?
Did you say don't worry about Gauss Jordan for the test?
Well, Gauss Jordan reduction is the RREF. Gauss Jordan puts a matrix into reduced row echelon form. So we've been doing Gauss Jordan, I just haven't used that word.
Okay.
Okay, what else? Jacob?
On the 7.4 homework, could we go over number 3?
7.4 homework. Number 3 is a sketch. So we gotta find the asymptotes and poles and intercepts and draw a picture that's reasonably accurate. So it looks like I'm not gonna have any holes because nothing's gonna cancel, right? Remember that the only way you get holes is if you can like factor your problem and something cancels out. Remember that if x plus 5 canceled out, if that's what canceled out, then the hole would be at -5. That gives you your x value, and then you would plug that into the part of the equation that's left, and that would give you your y value. Okay, am I talking a language you're understanding? Okay, we're not doing that in this problem because nothing cancels. The only time you're gonna have a hole is if something cancels. But we do have some asymptotes. Where are the asymptotes? They're vertical at 1 because vertical asymptotes happen when the denominator is 0. They happen when you cannot be. So x cannot be 1. Okay? Now, make sure that it's x equals 1. If you're ever confused, when you draw the line, whatever axis it crosses, that's the letter it is. And you gotta say x equals 1. You can't say just 1. It's a line. All right, what about horizontal asymptote? That's a 3. And again, it's y equals 3 because of this right here. Intercepts are points. We're not going to struggle with this. We're just going to plug in zeros and solve the equation. So when I put in a 0 for x, it looks looks like I get -6. And when I put in a 0 for y, remember, that's a 0, you're gonna multiply this over, so you're just gonna have 0 equals 3x plus 6, so that would be what, -2? So it looks like these are connected. And if those are connected, then we probably have this up here. If you're ever in doubt, or the problem, there's something weird about what's happening, go ahead and plot some points. Put 2 into your equation, put 3 into your equation, and plot the points.
For the horizontal asymptote, like if the top number is greater than the bottom number, like 5/3, do we just plug that in as a horizontal asymptote, or is that just not good?
Okay, wait, I don't understand what you're saying to me.
So like, you know how when you look at the horizontal
Mhm.
asymptote, and you like have to look at the number
Mhm.
next to the variable,
Mhm.
did you do that?
Yep.
So if 5 is on top and 3 is on the bottom, as an example, do we just put 5/3?
Yeah, y equals 5/3.
I just didn't know if that was like doable.
Okay, Jacob, the whole world is not even numbers, right? Their integers are, we love integers, but the whole world isn't integers. We can have asymptotes at fractional values. Yep. As long as the powers match, 5x over 3x is gonna be 5/3. Yep. All right, what else? Come on. It would be great if everybody passed this thing. Jacob, one more.
For number 4, we do a B,
For which one?
on the review tab.
Okay, which page?
Number, page 3.
Page 3? 2? Okay. Which one?
4B.
Okay, you need to show me, I'm not following what you want me to do here.
Oh, sorry.
Okay, so we're on
Never
page
know with those things.
1,
You played last class, yeah.
okay, so page 1.
I don't know, it might be
First
All right, so what he wants to do is A minus 2B,
kind of on brand.
and A is the matrix -1, 5, or excuse me, -1, 1, and 5, 6. And B is the matrix 2, -1, 3, 0. Now, first of all, is that a doable problem? Because sometimes it's not. That one's okay, because these are the same size. And addition and subtraction is all about being the same size. Now, before we subtract, we need to do that multiplication, regular order of operations here. So I'm gonna leave my A alone, but I'm gonna subtract. All right, now I'm subtracting, so I'm gonna subtract 4, -2, 6, and 0. I'm keeping the subtraction, so I'm just taking 2 times everything. Now I'll subtract. I'm gonna get a matrix that's the same size as the 2 I'm subtracting. -1 minus 4, 1 minus -2, 5 minus 6, and 6 minus 0. Did I do my subtraction right? That would be it. All right. Next time I see you, we're going to take a little test. We'll probably also begin chapter 9 at that time.